Hi guys, and welcome to this video. So once again we're going to be looking at iNav and how to tune iNav. Joining me once again is Mark Hoffman. Hi Mark.
Yeah, hi Darren.
Right, and of course I'll link to Mark's channel in the description, so go there, subscribe, bell icon, like all his videos, all that sort of stuff. I don't care if you don't speak German, do it anyway. Right, so here we go. Today we're going to be taking a look on the advanced tuning page in iNav and the fixed wing navigation settings. So where do you want to start, Mark? And what do these things do?
Yeah, I would say we just look at the advanced tuning page first, and we go through some of the fixed wing navigation settings listed here, and I will explain what each setting does and what is most important to set up to have a properly flying autonomous UAV. So the first thing you will have in the list here is the cruise throttle value. This is really important because if you give the plane too little throttle, it will just go too slow and stall. If you give it too high throttle, it will just burn up too much power without any reason, and you might even run out of battery when you are in return to home. What's actually not the best thing that can happen.
Of course, when you set this, you need to think about wind as well, don't you? So if you're working with a headwind, you'll need a little bit more.
Wind is compensated by iNav automatically. iNav had the minimum ground speed hard-coded in.
Oh, that's cool. I didn't know it had that. That's pretty...
Yeah, it has a 7 meters per second minimum ground speed, so as soon as it goes slower than 7 meters per second, it will automatically throttle up no matter what.
See, that needs to be something we can tune.
I think it will be tunable in 2.7. Because
cool.
we have, there's one developer working on in-the-loop speed control based on ground speed and...
or airspeed.
Ground speed and airspeed.
Oh, awesome. We're not cutting this out because that's really cool and people need to know about that.
Okay,
that would be awesome to have closed loop. So yeah, carry on. We're not cutting that out. I don't care. Okay. I made a mistake. It's all good.
Okay, so yeah, your cruise throttle is maybe the most important thing overall to have any autonomous flight modes and to have a reliable return to home. Then you have a cruise yaw rate. In the older iNav version, that was never in the GUI, it was only in the CAI, but it's a very useful feature actually, because if you fly like in 3D cruise mode with altitude hold and cruise to automatically follow a specific course you set with your sticks, and then you go into a turn, with this value you can determine how fast that turn can or should be flown by iNav. A too high rate will cause a too steep bank angle, for example. You can also get maybe trouble with some sudden wind direction changes if you cross, if you have headwind and then you fly through a side wind to a tailwind. And having a slower yaw rate in cruise mode will help you to, or will help the plane to adapt to different wind speed.
Is that limited still by the maximum bank angles in
Yes.
the angle mode? Or
yes, it's still limited by the maximum bank angles. So if you make it too sharp, the cruise yaw rate, then of course it will be limited by the capabilities of the plane. But I think as it uses the position XY navigation controller of iNav, where I'm not that familiar with yet, this controller could then freak out and causing snaking at the end if you set that too high. The next value is the manual throttle increase. That's really helpful if you like to fly to cruise with in Waypoint modes or in 3D cruise mode, because this allows you to actually go with the throttle higher than your cruise throttle you have set up here. But it's important to know where your throttle stick is all the time. If your cruise throttle is, let's say, 50%, and the stick on your radio, the throttle stick on your radio is below this 50% mark, the plane will just fly at its cruise throttle. It's set here. If you go with your stick higher, the new stick position will be your new cruise throttle value. So the throttle is still automatically adjusted, but around this new throttle point you set with your stick. That's really helpful if you want to fly manually against headwind, or if you have a waypoint mission and you just want to fly it faster than with the standard cruise speed.
Okay, and I'm guessing if you go back below about 50%, it will just use the cruise throttle as dictated by iNav.
Exactly, yeah.
Yeah. And I need to apologize for this. It's got a drop down for on and off. It should be a toggle like you can see on the cruise, the Crime Before Return to Home. I have put a fix in, but it hasn't been approved yet. But yeah, that was my mistake. Sorry.
So the next values we want to talk about is max throttle and min throttle. Usually these are, I think, at 1150 default and 1850. I like to change them a little bit to have a higher or a lower min throttle for glides in autonomous modes, like rapid descents. And the max throttle is very important if you have a plane that is very, very powerful, or if you fly, for example, with lithium-ion batteries that can't sustain the full throttle current all the time. Then you can limit the throttle value here to also limit your current flow from the battery during autonomous modes. And if you have a very, very powerful plane that maybe flies 180, 200 kilometers per hour or even faster, and you fly and return to home, you don't want to have anything going wrong and then crashing full throttle into the ground. So you may want to dial it down a little bit to not allow it going by itself into full throttle. So these three values here, the max bank, max climb, and max dive angles, are also very important. You might have seen them before when we looked at the rates tab here on the PID tuning page. We also have here max roll and pitch angles. These angles are the maximum limits for the angle mode, or anything, basically for the whole plane, for everything that is self-leveling. But on this page, the angles are the limitation for fully autonomous modes. That means if this value is lower than the bank angle on the rates tab, only navigation modes will be limited to these angles. If these angles are higher, actually, then they will be capped out at the maximum angles that are set in the rates mode. So the rates mode is the rates tab is the absolute limit, and this is the limit only for navigation modes. And of course, we have different limits for climbs and dives, because maybe you have a plane with some good power that can climb pretty fast. Then you can go higher here. But if the plane is also very heavy, you don't want to go over a specific dive angle, because it can gain a lot of speed by itself, and you want to avoid that.
You basically covered what I was going to ask then, is if they override the angles in the rates tab, but obviously they don't. This is up to that angle.
Yes, exactly. So the next value that's at least as important as the cruise throttle ratio or the cruise throttle itself is the pitch to throttle ratio. It's a little bit more complicated to explain. If your plane flies in any autonomous mode with altitude hold, it will maintain level flight with the set cruise throttle. Let's say, just for an easy calculation, the cruise throttle is 50%, so it would be here 1500, and you have a pitch to throttle ratio of 10. That means that on every degree pitch angle up or down, the throttle value will be reduced by 10 microseconds of pulse. So if I have a cruise throttle of 1500, a pitch to throttle ratio of 10, and I have a 10 degree up tilt in my attitude angle, for example, in a climb, then the throttle will be raised by 100 microseconds or 10%. And this is what the pitch to throttle ratio does. And to tune that well, it's pretty easy. You fly like in angle mode. you set your cruise throttle on your stick by hand. You look how fast your plane is flying in 3D speed. It's the best thing to look at 3D speed or maybe at ground speed. And then you just pull back, go into a specific climb angle, and you throttle up. And then you just have to look how much you have to throttle up to maintain that speed during the climb. It's only important to look at the climb, because on descent it will always go faster as it is on cruise. Just by nature, just by physics. So yeah, this dictates how much throttle is applied during a climb and how much throttle is reduced during a descent. Maybe in the future we will get a second value to have a different factor for descents, just to avoid overspeeding on steeper descents if we have a very low pitch to throttle ratio on a powerful plane.
And I guess these are again going to be limited by the minimum and maximum throttle values as well.
Yes, so you can never go above these max and or below these min values. That's true. Okay, the next one is something new. The next one is something new. That's throttle smoothing and instantaneous throttle. I think it was implemented in 2.6, if I'm right. Yes, it was introduced in 2.6, but I have not used it yet. So what it actually does is, if you have a plane or if you fly in an environment where you have some upwinds or falling air masses, and you are flying in autonomous modes with altitude hold, you have to constantly adjust your altitude. And this means you have slight pitch up or pitch down maneuvers just to keep track of the target altitude. In the past, it was that caused the throttle of the plane constantly going up, down, up, down, up, down. And the motor is constantly changing its speed. And with these settings, you are able to have some kind of deadband. That's the instantaneous throttle adjustment threshold in centi-degrees. So let's say I set that to 50. Then at an attitude or at a climb angle or descent angle of up to 5 degrees, the throttle will not change. So pitch to throttle ratio is not taken into account. And then you have throttle smoothing, and this only does insert some kind of filtering, so the throttle is raised gradually if you have some sudden altitude changes, instead of going instantly and having the motor winding up and down all the time. So the next value is our loiter radius. That's pretty self-explaining if you are in position hold or if you are on a return to home. That's the distance from the actual home point or from the target loiter point the plane tries to maintain. Of course, on bigger planes, this should be a bit bigger, and you always have to be aware of that the plane can maintain this turning radius with the given max bank angle, for example. If the bank angle is too shallow or the loiter radius is too tight, this can cause navigation errors, and then you get weird stuff like the plane suddenly leveling out, flying in a straight line out, then coming back and try to loiter again. Yeah, so this needs to be adjusted a little bit on bigger planes. On iNav 2.7, this value will be raised a little bit by default, I think.
Yeah, it's 75 meters.
Or 75, yeah.
Yeah.
Then we have loiter direction, also pretty self-explaining. Do you want to have a clockwise turn? That would be right, or an anti-clockwise turn, that would be left. Or you can set it to your control, so the default when the plane goes into a loiter is right-hand side.
Yeah.
And if you use your yaw stick and push it to the left, the plane will turn around and make a left circle. The last thing we have is the control smoothness. What this does in functionality, I'm not sure how it works in the background, but function-wise, it limits how aggressive or how fast the plane will start to turn or to roll when it goes into a turn. And this will just give you a more gentle and more scale-like flight behavior in navigation modes if you go into a turn like return to home or in waypoint modes. Yeah,
that does mean that it's slower to react, which is the only downside of it.
Basically for very big planes, if you fly Sky Hunter or XUAV Clouds or whatever, very big plane, and you want to have smooth camera footage, and you don't care about acrobatics or quick reacting flight behaviors. And then we have two more settings that only accounts for waypoint missions. We have the waypoint radius. This one is by default on 1 meter, no matter if you select plane or copter. If you fly with a plane and you want to fly waypoint missions, make sure you raise that value, because it's really hard for an airplane, especially if there's some wind, to hit a waypoint target that's just 1 meter in radius or 2 meter in diameter with the coordinates. Especially if you have a very slow update rate on your GPS, like with the standard uBlocks protocol. So I always set this to 10 meter radius, so I have a 20 meter wide area the plane has to hit to mark the waypoint as valid and continue to the next one. And you have the waypoint safe distance. This is the maximum distance the first waypoint in your mission is allowed to be away. And you are still able to arm the plane. If the first waypoint is too far away, you are not allowed to arm the plane, because this could cause really nasty flyaways. Yeah, I think that's basically all about the main navigation settings in iNav.
There are obviously the question marks down the side just for a reminder of what they do. But we do have the iNav Fixed Wing Group Pro OpenTX model, and some of these features can be adjusted in flight. So yeah, you don't have to do everything in the configurator. You can do some of them on this screen here.
Yes, exactly. I've showed you this screen already when we talked about the PIFF tuning. And here I show you the screen again with all the items that we have in there. So up here we have the roll, pitch, and yaw PIFF values you can tune in flight. And the big advantage of in-flight tuning is you see instantly how it changes your the flight characteristic of your plane. And you don't have to land, change the values, save, reboot, launch again, and then see what happens. And if the values are not good at all, even bad things can happen and you might not be able to launch anymore. So what we have here is we have the cruise throttle and the pitch to throttle ratio. So you can do the pitch to throttle ratio tuning mid-air. That's very handy. We have the alignment pitch. This will, by the way, with iNav 2.7 change. There will be a new value for that. We don't need to use the sensor alignment anymore. I talked about that in the Wing Talk already. Just look at the beginning of the last Wing Talk and you will know what I mean. Then we have...
Just because this video might be out after the next Wing Talk, it's the February Wing Talk.
Okay, thank you. Then we have another very interesting thing that's not in the configurator GUI, but I wanted to have it on the OSD. That's a zero throttle down pitch. What that means is if you have motor stop overriding your navigation modes, that means you lower the stick to 0 and your motor stops even if you are in a navigation mode, and also if you fly in angle mode, for example, or horizon mode, what the plane does, it automatically pitches the nose down to a specific angle you can set here. So this is really, really good if you you're a little bit far away, or you're flying high and you running out of battery. You just cut the throttle, the plane will nose down. If this is tuned well, it will maintain a perfect glide angle, and you can glide as far as possible with this specific plane. And you just set a specific angle here the plane needs to maintain a constant airspeed. Then we have our TPA we talked about in the last video. We have the TPA breakpoint. Then we have here the level P value. You can ignore the LPF and the horizon transition value here. That's not in the OpenTX Pro model, so we cannot set that up. It's just one single item. But here you can set the level strength. And here we have the position XY PID controller, and with this one you can adjust how aggressively the plane will follow its path or will make turns in any navigation mode. That's really handy to have wider or closer radius of your turns if you are in a navigation mode like waypoints or in return to home. And the last value here is the control smoothness. And we talked about that before. You can set that to have softer turn injections. Is that the right word? You have softer starts or endings of turns in navigation modes and also in angle mode.
Yeah, so softer transitions between attitudes, I guess.
Yeah.
Okay, so while we're on the screen, there's quite a few different, like I can see two speeds up there, altitudes. So how are these used in relation to the tuning? You mentioned 3D speed is good for the pitch to throttle. So is that on this screen? So we got all the information that we can get at straight away?
Yes, here's basically everything inside that OSD we need for the tuning. So these two throttle values here on the right side, one is manual throttle, the other one is auto throttle. We have our watts and amps to have real-time information how many power the plane is pulling, and we can use that later for things like battery estimation and all that stuff, or just efficiency optimization. We have our roll and pitch angle down here in the corner. This is also very handy to tune the board pitch alignment to make sure in altitude hold this pitch angle has to be 0, and we can tune that in real time by changing this value. We have our climb rate. We can use that also to tune the board pitch alignment by using angle mode, and then change it until the climb and descent rate is 0. We have our altitude, general item we should always have in our view. And the two speed values here are, the first one is airspeed. If you have an airspeed sensor, it's already there. And we have the 3D speed that includes also climb and descent rate to calculate your speed in 3D space.
Cool. So everything is pretty much covered in this this tuning system.
Yeah, and of course this screen is not meant to be used for normal flying, but only for tuning purposes.
Cool. Just a minute, while we're on this screen with the model, you can use this screen still for auto tune. You just make sure that you don't have any of the parameters flashing, and auto tune will work fine. Hi guys, I thought I'd just interrupt the video just to let you know what's going to be happening with this series in the future. So you may have heard in this video we mentioned iNav 2.7 a couple of times. Now, as of just over a week ago, it was actually announced that it was now going to be iNav 3.0, and Pavel actually released a video on April the 1st, which people thought was an April Fool's joke, but here it is. So you can see on the configurator, iNav 3.0, the firmware I haven't actually updated yet, but you can see this is live. This isn't Photoshop or anything like that. It is going to be iNav 3.0. But anyway, so getting back on topic, it's going to be iNav 3.0, and a lot of the reason for this major version jump is actually because of changes to the fixed wing side of things. In particular, how to tune the plane. For example, there's automatic board alignment coming, there's a PIDFF controller, and the auto tune is going to be enhanced with actual rate setting. So that's just 3 things, but there's a hell of a lot more coming in this next version of iNav. So I spoke with Mark, and we decided that we're actually going to pause this series here. We've actually given a fair amount of information. So previously we've given, how to do the auto tune. We've spoken about what the individual parts do. Mark's demonstrated him doing a manual tune, or a partial manual tune in flight. We didn't go into the in-depth stuff, but the in-depth stuff will still be the same with 3.0. And obviously in this video, we've gone over the navigation settings in the advanced page. And the in-flight adjustment using the iNav fixed wing group OpenTX model. So what we're going to do is we're just going to take a break from the series. We're going to wait for iNav 3.0. The earliest will be a release candidate, but probably get a final release out so we know exactly what's going to be in there. And we'll continue the tuning series with iNav 3.0. And of course, there will be stuff that's still relevant to the older versions if you're deciding not to update. I mean, there's people still running iNav 2.1, so it does happen. But we will still include things that will be relevant to older versions as well. Stuff like tune the pitch to throttle in flight. We've sort of gone over it, but we haven't shown how to do it. So there's a lot of stuff that we can still cover, and we will be doing that once iNav 3.0 comes out. So I just wanted to give you guys an update of what's going to happen. So what I would do if I were you, if you're interested in this thing, make sure you subscribe and click the bell icon, and when those new videos come out, you'll hear about it and you'll be able to catch up. So anyway, I'm going to get back to the video that we recorded probably a few weeks ago now, just to finish up, and I'll see you in about 2 months back on this topic, maybe 3 months, with iNav 3.0. So thanks guys. I think it's probably a good place to wrap the video up. We've basically covered everything in the advanced page that relates to tuning for navigation, and we've covered where it is for tuning it manually. So I think it's a good place to end for the minute. What do you think, Mark?
Yeah, that's totally fine for me. And we will cover more in-depth things in the next videos.
Cool. Right, so thank you very much, Mark. And thank you everyone for watching. Don't forget to like the video, subscribe. It will help share it with more people so they can learn how to do this. Don't forget to like and subscribe Mark's channel. And thank you very much for watching, guys. See you on the next one. Bye.